Hello, everyone. Welcome to the online open course on Industrial Robot Application Technology. The method of communication directly determines whether a robot can be integrated into a system and supports the complexity of control. As one of the most common modules on the robot control cabinet, the I/O communication module plays an important role in product control and operation. Now, let's learn about the commonly used I/O board signal configurations for FANUC robots together. In this lesson, we will mainly explain through two parts. 1. The types of I/O signals commonly used by FANUC robots. 2. The distribution of I/O for FANUC robots. Let's first learn about the common types of I/O signals for FANUC robots. For FANUC robots, there are mainly two types of I/O signals: general-purpose I/O signals and special-purpose I/O signals. 1. General-purpose I/O signals. General-purpose I/O signals include digital I/O signals, analog I/O signals, and grouped I/O signals. 1. Digital I/O signals, also known as DI/DO signals, involve standard digital signals input or output by external devices through the I/O interface. These signals have values of on and off, which can also be represented by binary 1 and 0, or in timing diagrams as high and low levels. 2. Grouped I/O signals, also known as GI/GO signals, define a group of 2 to 16 signal lines as one unit for general digital signals. The value of a group signal is expressed in decimal or hexadecimal numbers. After conversion to or from binary, data exchange with peripheral devices occurs through the signal lines. 3. Analog I/O signals, also known as AI/AO signals, are used for analog input and output voltage value exchange between the robot and peripheral devices via I/O modules or I/O units. During read and write operations, analog input and output voltage values are converted into digital values. The digital values obtained from analog I/O depend on the reference voltage and may not exactly match the actual input and output voltage values. 2. Specialized I/O signals. Specialized I/O signals include peripheral device I/O signals, robot I/O signals, and operator panel I/O signals. 1. Peripheral device I/O signals, also known as UI/UO signals, are specialized signals that have a defined purpose within the system. These signals connect through the processing I/O printed circuit boards, or I/O units, with programmable devices, such as signal control cabinets, PLCs, etc., and peripheral equipment for external robot control. 2. Operator panel I/O signals, also known as SI/SO signals, are digital-specific signals used to exchange data between the buttons and LED statuses on the operator panel or operation box. Inputs are determined by the on/off state of the buttons on the operator panel. Outputs cause the LED indicators on the operator panel to change according to their status. 3. Robot I/O signals, also known as RI/RO signals, refer to digital signals used by the robot as end effector I/O. They are utilized after connecting to the connectors attached to the robot's wrist via the end effector I/O. Let's continue to learn about the distribution of FANUC robot I/O. Among the 6 common types of I/O signals mentioned above, the configuration methods for 3 general-purpose signals are essentially the same. We will explain this using the configuration of digital I/O signals as an example. It is important to note that operator panel I/O signals and robot I/O signals are somewhat special and cannot be configured. Next, we will detail the steps for configuring a digital output signal DO8 and a digital input signal DI8 as examples. 1. Allocation of digital output signals. 1. Press menu. Select the 5 I/O option in menu 1, press F1 type key, and choose 3 digital option to enter the I/O digital output menu. 2. Click the F2 assign key to enter the digital output signal assignment interface. Move the cursor to the DO1 to 8 range bar and enter the signal range 8 to 8 you want to configure. 3. At this point, the status bar changes from active to penned. It should be noted that the status bar indicates the state of signal allocation, where active means the signal allocation is effective and in use. Pen means the allocation is valid and will take effect after restarting. Unage means not assigned. Inval means it has been assigned, but the corresponding device is not connected. 4. The physical address of a FANUC robot is composed of the rack number plus the slot number. The rack is used to define the type of I/O module, and the rack numbers for commonly used I/O modules are predefined. Here, we use the CRMA15/CRMA16 communication module. Move the cursor to the corresponding rack bar for the signal and enter the value 48. 5. Move the cursor to the corresponding slot bar for the signal. Since the CRMA15/CRMA16 communication module has only one slot, enter 1 here. 6. Move the cursor to the corresponding start point bar for the signal. The value entered at the start point is the physical address corresponding to the signal, which should match the signal you intend to use on the communication module. Here, enter 8. 7. Restart the robot and check that the status of the previously configured D08 signal has changed from pen to active, indicating that the signal allocation was successful. 2. Allocation of digital input signals. 1. Enter the I/O digital output menu. Click F3IN/out to switch to the I/O digital input menu. Click the F2 assign key to enter the digital input signal assignment interface. Move the cursor to the D01 to 8 range bar and enter the signal range 6 to 6 you want to configure. 2. The subsequent settings are basically the same as those for outputs. Enter 48 in the corresponding rack bar for the signal, enter 1 in the slot bar, and enter 6 in the start point bar. 3. Restart the robot and check that the status of the previously configured DI6 signal has changed from pen to active, indicating that the signal allocation was successful. That concludes today's lesson. We have learned about the common types of I/O signals used in FANUC robots and how to allocate these signals. I hope you can master this knowledge and apply it in practice. Lastly, please complete the following exercises. See you in the next lesson.